Hello and welcome back to the channel. In this video, we're going to be learning about data types in Java. So data types is not something that's entirely new. It's just the different types of data. For example, your data types could include things like numbers, letters, decimals, or words. Numbers could be things like the numbers 3, 5, 13. Letters could be just characters or alphabets like A, B, I, or L. Decimals are just numbers with a decimal point. So 8.6, 2.012 are all examples of decimals. And words is just a collection of alphabets. So something like hello or Java are examples of words. This is not entirely new because we use data types in our everyday life as well. Here, since our decimals are also basically numbers, we'll actually change the numbers above to integers. Now there's a clear distinction between integers and decimals. Decimals are the numbers which have a decimal point. Integers are numbers which don't. And we're also going to add a different type of data. We're just going to call these characters. If you look at your keyboard, you're going to see that you have special characters like the dollar sign, the front slash, the hashtag, and all of them are also examples of types of data. In Java, we have two main types of data. We have primitive data types and we have non-primitive data types. And they're really different. Primitive data types are the ones which are inbuilt, and these are provided by the Java programming language. So you can just open your code editor or IDE and you can use your primitive data types because they're already inbuilt. However, our non-primitive data types are user defined, meaning you as the programmer are going to make these non-primitive data types. They are not inbuilt. Now we also call our non-primitive data types composite data types because basically our non-primitive data types use our primitive data types. Our primitive data types act as building blocks to make our non-primitive data types. So if you look at our primitive data types, there are really four types of primitive data types. And these are the same ones that we've seen before. They are the fundamental ones. So the first one are integers. Integers are just numbers which don't have a decimal point. So something like 3 or 0 or -5 are all examples of integers. The next primitive data type are basically characters or letters, and this could just include things like the letters of the alphabet. The other type of data are decimal numbers. Decimals are just numbers which have a decimal point. We also have something called booleans, and I know I haven't explained booleans before, but they're really simple. You'll understand how they work later on. So now we're going to take a look at each of these primitive data types. The first one are integers, and you can see that there are really four types of data types even under integers. And this is confusing. Integers are just numbers. How would you have four different types of numbers? Now the thing is, all four of these are examples of just numbers, but they vary depending on the size of the integers. So the byte data type is usually used to refer to really small integers, while the long data type is used to refer to extremely large integers. And it makes sense why we have this difference. Different numbers occupy different space in memory. Depending on the size of my number, I can give it a certain data type and therefore allocate the required memory. So if you look at this, our byte only requires 8 bits. Something like a short would require a little more. It requires 16 bits. Remember, 8 bits is 1 byte. So our short is going to occupy 2 bytes of memory. Our int, on the other hand, requires 32 bits. And this is just 32 by 8, 4 bytes. Our long requires a lot more. It requires 8 bytes or 64 bits. So for extremely small integers, I can use something like a byte or a short to save space. But for extremely large integers, I'll be required to use something like a long or an int. Usually, we're going to use our int. We rarely use something like a byte or short in programming. Next, we'll take a look at decimals. So even under decimals, there are two data types. We have float and we have double. And we have the same distinction. A float is used for smaller decimal values, and a double is used for larger decimal values. So something like 3.3 could be called a float because it has a lesser number of digits after a decimal point. However, something like 3.3567 is called a double because it has a larger number of digits after a decimal point. But this doesn't mean that something like 3.3 is not a double. 3.3 could also be called a value of the double data type. So then we have a question. If 3.3 could be considered both a float and a double, how do we distinguish between a float and a double? To do this, we actually just add an f after a float value. So when I say 4.2f, it means that it's of the float data type. When I say 4.2, it means that it's of the double data type. This isn't what we do in real life because we don't really have these many different types of data under decimals. But in Java, whenever you refer to a float value, you will have to use an f after that float value. So something like 3.14 is a double, but 3.14f is a float. That distinction is very important. Since our float value is generally smaller, it only occupies 32 bits in our memory, which is 4 bytes. A double is much larger, so it occupies 64 bits or 8 bytes. The next data type we have are letters and characters. Now, under letters and characters, there's only one data type. We just call it car. So our car data type could include letters and characters like these. We see that we have alphabets like A and C. We have special characters like the dollar sign and a hashtag. But we also notice that even digits could be considered as a character. And this is true. When you look at your keyboard, all of these digits are examples of characters. But there is a difference between the character 3 and the integer 3. All values of the character data type are inside single quotes. And using that, we can differentiate between the character 3 and the integer 3. Now, another thing that's important is that our characters for digits only includes all digits from 0 to 9. So something like 23 or 33 are not characters. All digits from 0 to 9 are only considered characters. And our character values occupy only 2 bytes or 16 bits in memory. The last data type that we have are booleans. Now, booleans are pretty simple. If we looked at something like integers, we could have an infinite number of possible values. But something like booleans, there are only 2 possible values, true or false. We'll understand where booleans are useful later on, but for now we can just know that the boolean data type could include just 2 possible values, true or false. And a boolean value would occupy only 1 byte in memory. So basically, when we talk about data types in Java, under primitive data types, there are 4 main classifications. You could have integers, decimals, characters, and booleans. And under them, you would have different data types depending on the size of the value. So something like a long would occupy more space in memory and is used for larger integers, while something like byte is used for extremely short or small integers. But even though we have multiple data types, the main ones we're going to use are int for integers, double for decimals, char for characters, and booleans. Non-primitive data types are a lot more complex, and we'll learn about them much later in programming. But the general types of non-primitive data types are strings, arrays, classes, interfaces, and many more. Remember, these are user defined, so there are different types of non-primitive data types. And that's it about data types in Java. In later videos, we're going to make variables and we're going to assign them values using these data types. Thank you for watching and have a great day.